So I put out making a guitar body in FreeCAD, and interestingly, I've received a lot of comments on the transitions. And this is one method that I have of doing a guitar neck transition in FreeCAD. Now, some of the weak points of this method are it produces a lot of faces, and that produces some complications with trying to fill it further. However, after running Booleans and other things in FreeCAD, I think something as complex as this with as much detail may have some inherent filleting problems no matter what is tried. So I think a fillet that won't generate could be somewhat inevitable depending on the kind of transition that you want. Given that, I think FreeCAD is doing an excellent job at being able to handle complex transitions. So the approach that I'm taking here is a solid modeling approach. You can do this with solids. Now, a more powerful method would be a surface modeling approach. I've got a video that I've already uploaded where I cover building a computer mouse in surfaces, converting it to a solid, and moving from there. And I think that might be a helpful reference for a second method. You would just apply the principles of the computer mouse to the guitar neck. But since I've already covered that principle with surfaces, I want to show a way to do it with solids, which is probably a little bit faster and easier, albeit we have a little bit of weakness with generating a lot more faces than we need than if we were to do that with surfaces. So let's get started here. I'm going to start out with a guitar neck. This is just a generic model that I made, and you can download this from GrabCAD. The link is in the description if you would like to follow along with the video. So download this if you want to follow along. Let's get started first by making a datum plane. I will switch to the part design workbench where I've been working out of. The part design is such a wonderful and nice workbench. I like using it whenever possible. It's been my default for most projects. Now we want to highlight a plane, and we care about our XY plane. So we'll go into the tree, highlight my XY plane, and create a datum plane where I can offset this in the Z direction, say 1,000 millimeters. We're going to say OK. We're going to sketch on this plane here. And now I want to make a larger sketch of my neck, just larger version. So I'm going to make a line, and I'm going to switch to a end and rim point 3-point arc here. So I'm going to hit T for tangent. Again, that's the T key. I'm having a little bit of a problem. I upgraded my version of Linux, and for some reason my keyboard monitor seems to have disappeared. So I don't have my hotkeys available, but I'll just call them out. Again, T for tangent. And then here's our arc center point, which we will make V for vertical with our end point. Finally, I can add some dimensions here. I'm going to say Shift V for a vertical dimension. We'll make that 150 millimeters. And then let's go to this arc, Shift R. We'll make that something like 5 millimeters. And then I think I just need to constrain the length of this line. So I'm going to say not Shift V, rather, but Shift H for horizontal dimension. We'll make that 200 millimeters. We'll come over into our sketching options up here. Let's actually highlight here, here, and here. So I've highlighted everything that I've sketched so far, and then I'm going to highlight my vertical sketch axis. Somewhere in these options, which you can see right here, you have a mirror option. So I click on that and mirror my sketch. And then I'll simply apply an E for equal constraint between these two lines. And let's see where else. I want to go C for coincident. Between these arcs, E for equal. Maybe I can select these arcs T for tangent. And then I can put this endpoint coincident to this endpoint with C. C for coincident. And we have that. So I'll use the spacebar to hide my datum plane. Alright, so in FreeCAD you can reuse your sketches. So I've consumed sketch 001 within this additive loft. However, I can highlight it as that sub item in my tree. I'll choose loft, we'll add a section and go out to this line, and now we've lofted our neck quite large, right? That looks like, I think there's an instrument out of Asia that has a large flare at the end, but I can't remember what that instrument is, but it kind of reminds me of this random instrument I've seen before. So this is kind of cool, but we want more of a good old, guitar head. I would associate something like the, those classic Stratocasters. Those things are pretty cool. So let's make it look like that. All right, we don't want this to be our final product. That would probably be very heavy. So let's create another sketch. I'm going to make sure that nothing is highlighted in my tree. Click the sketch button, and I'm going to choose my base XZ plane. And I want to sketch out a profile that looks just like my neck, right? From the top view. And actually, I'll start with the X key, X like X-ray. I'm going to choose this outer line and this outer line here. That's all right if I can't choose that. There we go. So I just chose my outer lines. And let's create a nice arc. In fact, let's close this first, right? I'm getting ahead of myself because we've got a sharp transition here. Now there's a few ways to deal with this. I think lofting normal to profile is one way that you could. Normal to profile lofts are something that I know you can do in some platforms. I don't think FreeCAD has that option. And so to replace that, I'm going to put a fillet in here. And we can make that kind of a large fillet. What if I did 75 millimeters, right? And that sort of simulates what a normal to profile loft could look like with certain settings. That's going to be good enough for what we're doing here. You can see already the way that we've generated so many faces and the way that we have so many lines that are converging onto a single point. That can be difficult to fillet later, right? So there's pros and cons to adding a fillet now, but I would say that I care more about a nice curvy organic transition than I do about adding fillets later on. But with your design intent and your priorities in what you model, that could be completely different for you. I'm going to accept that and say OK. But for me, I think I'm going to go with a smaller transition down to 50. Now with my sketch, I'll go back into my sketch. And let's close that. In fact, notice our sketch comes before a fillet in the history tree. So I'm going to delete that because I'd like to sketch with my fillet implemented. I think that would help my design. So now my fillet is showing up in my sketch. I hope I haven't delayed you too much in all of that. Let's X to import again. And I can import this line and this line. They're just about perfect. We will add an arc. I'm going to say Shift R to determine the radius of the arc. That will be, how about 50, right? Just like our fillet radius. Now we'll take my arc center point and my arc end point and say H for horizontal. So now that we are horizontal, I want to add in another arc. Now I'm going to say T for tangent to make a tangent relation with my arc. And let's give this arc a radius. How about 50.8, right? Shift R, 50.8. And then we'll come over here and add this line up here. We're going to say T for tangent. And now I'll make another arc up here. X to import, right? X, and then choose this arc in my imported line, and T for tangent. We go right up to the very end, and we're going to say T for tangent between these. If you do have any kind of problems in the future, you may look at this as some kind of zero thickness, but I don't think that this is going to be a problem for zero thickness under almost any circumstance, but it's something to be mindful of. Now we're going to say 30. And then, oh, how about I select an angle, so I'm going to hit the A for angle key. Select these two lines. Looks like that didn't quite take. Hey, how come it's not letting me angle? What the heck? Okay, I'll try this line over here. Nope. I'm just going to draw. Oh, I know why. This probably imported as a B-spline because I did a loft. So this isn't a straight line at all. That makes so much more sense. Not the software's fault. That was my fault. So I've got an invisible or construction line here. And I'm going to choose here and here. A for angle, 150 degrees. And that's looking pretty good. All right, so we have 3 degrees of freedom. And it's all up in here, right? I think my first degree of freedom if FreeCAD will let me move that down here. There we go. Maybe I'll grow this to 75 millimeters. Right, in fact, I'll do this. I'll take this down to 50. We'll do X for import. Select that line. I'll select this outer line. Take this outer line and say T for tangent. Ah, that came in as a B-spline. Of course it did. So there goes that brilliant idea. But I can Shift V. Let's just give that 760 millimeter height, right? That constrains most of what we've got pretty simply. And I think we're down to 2 degrees of freedom. Looks like both degrees are probably somewhere in this arc. So we'll go back to driving geometry up here. Grab our arc. We're going to say T for tangent again. We're going to say T for tangent again. We're going to make another arc. We're going to say T for tangent. And a final arc that will end us up right here. We're going to say T for tangent. And we're going to make this H for horizontal relative to its center point. And so there we're starting to look a little bit more like a classic guitar sketch. We're going to say Shift R and make this 135. We can give this a height, Shift V for a height of 890. And then Shift R again, maybe we'll make this 80 millimeters. And Shift R will make that 100 millimeters. And then this guy, Shift R, will make that 140. Starting to look more and more like a good old classic guitar head here. Still are wrestling with some degrees of freedom. So I'm going to select this point and this point and say H for horizontal. And I am getting green everywhere, even though this is saying 1 degree of freedom. I'm not exactly sure where that degree of freedom is. Oh, it must be here. Right, so an arbitrary construction line, we're going to say E for equal length. There we go, no degrees of freedom. I could have sworn that would have fully constrained everything, so I guess it makes sense it was a construction line. Now you can do a Boolean here, right? There are many options. Now, I think a lot of people will look at what I'm doing as not polished, but if I were to just, close this sketch off here and do something like a flip side to cut, which is available in other platforms, I'm running a very similar operation in other platforms to what I'm running in FreeCAD. So I don't think it's too onerous what I'm doing. Shift H for horizontal distance, I'm going to say 175. You can tell I've just drawn a border around here. Let's say Shift V, say something like 350. E for equal. Right, now we're fully defined. So let's close that. Right, so we're looking at a pretty nice little guitar head there. And we're going to say extrude cut. We're going to say through all, symmetric to plane. Okay. So we've got a nice little guitar head. And you can see the cut has generated many faces. And that's one of the reasons why I said that this method is a downside compared to like a surfacing approach, which you can see in another video that I should have posted in an aforementioned manner. So let's go through now another cut. I'm going to clear up my view a little bit by going to a wireframe view. I'm going to create a sketch, and we'll do so on the YZ plane. And let's do a sketch up here. This should be about as much fun as the last one. I will not judge you if you fast forward. Let's import some geometry first. So we'll go here to here. And I'm going to start with an arc. All right, I'm going to say T for tangent. Oh, of course that came in as a B-spline. Since I lofted the neck so that it would lose a little bit of size as it goes up, like I think how real guitars feel, these come in as B-splines, and so I need to draw a line. We'll say V for vertical. I'll say Shift V to give it an arbitrary dimension. Let's say 5, doesn't really matter. And now T for tangent. You also could have taken the arc and added a horizontal relation to the endpoint to get a tangent to vertical arc like that. Let's go back to driving geometry and add in another arc. From here, I'm going to be simple and make this not only T for tangent, but E for equal, so that these arcs share an equal radius value. And we'll do exactly what we said before. We'll take the midpoint of, or the center point of this arc, go to the end point of this arc, H for horizontal. Let's say Shift R 45 millimeters as our value. Actually, you know what? Let's go back and make this 100 millimeters. I think that'll be a bit more realistic. Now, I want to import with the X key, of course, this point. And we'll take that down a hair. We will come all the way up here. And we'll kind of meet at this point. Now, maybe this is getting it to be a little bit more zero thickness-ish. So, just to avoid even a possibility of zero thickness, we'll go make a vertical line that goes past this. And I think that should resolve it, at least reasonably well. Highlight this line, Shift V for distance. Let's go down to 165. And then maybe I need to constrain this, right? So we'll select the height of just this arc, Shift V 45, right? That might not be practical dimension for manufacturing, but you can make it, wherever, reference whatever you want to. This isn't really a practicality video. This is just a video intended to introduce a workflow on making a guitar head transition. Let's go to Shift H and make this, say, 30 millimeters thick, or whatever thickness your design intent would like to be. Maybe I'll make a center point arc. So I'll switch to center point, and I'll choose this center point to make these arcs concentric. Now I'll choose this end point of the arc, this center point, H for horizontal. Shift R, maybe we'll give this a value. Oh, well, let's cancel that. In fact, let's cancel this. Okay. let's choose a 3-point arc here. We're going to say between these two, T for tangent, and Shift R for radius, 45 millimeters. And then we shall make a 3-point arc. T for tangent, T for tangent. Oh, of course, it looks like we've created an impossible situation because it's a B-spline, of course. We'll choose this midpoint or the center point of the arc and choose a horizontal relation. Bam! There we go. So we've got a nice little taper on our guitar head, and same method as before. So we'll choose this here and make a little boundary around. Again, you can do this with Booleans, especially if you play your cards right. If I were to do this with Booleans, I would probably make my neck last. I would Boolean out the head by extruding these sketches, except of course I would, close the sketches off here instead of drawing a layer around them. I would just extrude all the profiles, do a common Boolean, and then loft out the neck. Okay. So with that being said, maybe I'll just fully constrain this here. Shift H, we'll give this 25 millimeters. We'll give this 285, right? Shift V, 285. Maybe we'll give this something like 200. Shift H, 200. You just have to be bigger than, the body. So with that closed, how about we do a pocket? And we'll go through all, symmetric to plane. I can switch my view back to as is and accept that. Excellent. Now, if you want to fillet this, rule number 1, save before every fillet, because when you have fillets that converge like this, right? Multiple edges are converging onto a single point. Especially right here, right? You have 2 edges that converge into one and keep going. That is a recipe for disaster. That's computationally difficult. Now, SolidWorks can deal with this pretty well. A Libre can deal with this pretty well. I think this is a great opportunity for further development in FreeCAD. That is not a criticism because FreeCAD was built by volunteers and is given free to anyone, and something that noble in the world I don't think should be criticized, but that's only my opinion. So I'll highlight this edge, right? I've saved, and if I try to fillet this, we can actually add a fillet, which in my opinion is very impressive. Right? Maybe I'll make that 4 millimeters. I'll select this edge and make a fillet, and of course we crash. And you can see my gorgeous, absolutely gorgeous Supra desktop background. And so if this image is copyrighted, I might have to delete this part of the video, but as of right now, what a beautiful car. So we're going to go back to FreeCAD. So that's an example of what crashing looks like, and it is for the aforementioned problem with fillets converging on multiple edges. Right, so and that seems interesting that we've crashed, but then we've recovered, and as we've recovered, this edge is filleted. Truly, as I sit here recording this, I have not seen that happen before. I'm kind of like that guy on that movie that's like, actually, I'm more impressed than anything. So, who knows, maybe intentionally crashing it is a great workaround for fillets. But hey, you've seen it here first, folks, unless otherwise specified. So I'm going to save that because that's kind of incredible. Let me upload this to GrabCAD. I don't know if this would help anyone who's really good at developing at all, but that could be an interesting case for someone who develops or debugs. So I'm going to do a save as. So I'm making this guitar neck video 1. That will be the interesting fillet one. If anyone on the development side wants to review the file, and then guitar neck video 2 will be, whatever I do next. So let's just do a little experiment here and see if this edge will fillet. We'll head on back to part design. We have this edge highlighted. We'll say fillet, and it looks like we're unable to create the fillet. We'll come up here. Now, this could cause some confusion because we have many surfaces that are converging onto a single point. So I'm going to hold Control and select 2 points to try to give this, our best chance. Actually, I have to remove this edge. All right, so I'll get this edge, fillet, and we crash. Okay, so you get the idea. Filleting is very difficult. FreeCAD isn't the only platform that has problems with some kinds of fillets. A long time ago, I did a little fillet experiment between Onshape, which in my opinion is the best cloud CAD available right now, if you're willing to have your stuff be public domain. And I compared Onshape and the 3D Experience platform XDesign. And if you're thinking about XDesign, just go with Onshape. But anyway, we're going to go with our guitar neck. This is the sample that we started with. So that's transitions. I guess I better wrap it up. That is a way to do guitar neck transitions. Again, a surfacing approach could eliminate some of the difficulties and problems that we have seen. So try surfacing if you are not satisfied with this method. Hope this was helpful. If it was, please subscribe. I'll see you in the next video.